Yeah, very warm welcome from me also tonight, because tonight it's also dark outside here, to this Data Minds virtual meeting. And we have the topic SQL to KQL. And let me see if I can get this to work here. Oh, yeah. So that's me. My name is Thomas Hütter. I'm from Germany. And I work as a developer for ERP. We just discussed it a bit. I'm fighting against the Business Central systems at an end user company. I know a thing or two about SQL Server. I've been dealing with SQL Server for, 30 years now. I think I started with version 6.5. Anyone remember that? 6.5? Yeah, right. So 30 years with SQL Server. Yeah, I've done a couple of other things in between, like starting with R and Power Platform and Arduino computers. And I've been speaking at SQL data events somewhere around Europe, from Iceland to Slovenia. Also some big conferences like SQL Bits. I've done a couple of events in Belgium also. I've been to Techurama and also Data Minds Connect one time. And also, yeah, the symbol on the bottom right, I did several SQL Saturdays, or how they call today, Data Saturdays. So I enjoy traveling around a little bit. So what are we up to today, or tonight rather? Just quickly push it up here. Um, a quick introduction where you're coming from. I guess we all are familiar with the SQL, the structured query language. I'm not sure that the data mines, did it have a name with SQL before in the name? I'm not sure. Um,
Yes, we did. We used to be called SQL UG, SQL
yeah,
User
I, I,
Belgium.
I thought you had renamed it at some point in time. So okay.
Yeah.
Yeah, so it should sound familiar to you. We're looking at taking a closer look at the select statement, and then we're going to look at KQL, how that translates to KQL, how we can use that in the Azure Data Explorer, which is the online solution. I have some hands-on examples, of course, and yeah, we'll probably have enough time to go to visualizations and dashboard and that sort of stuff. And I'll share my resources with you as I usually always do. Where are we coming from? Well, what SQL? Yeah, in a SQL user group, or that's a question everyone can answer probably. Yeah. Set-based, domain-specific, 4GL, blah, blah, blah. First released by IBM almost, no, it's just like, let me think, 50 years ago. Based upon the relational algebra, everyone should have heard the name of Edgar Cott before, and his relational model of data, because that's what makes the SQL engine work. That's what it's based upon. Of course, it's used mainly for managing relational databases. And there are standards, would you believe, by the ISO and also by the ANSI. The most current versions that I've found are from the year 2023. But be aware that all the vendors like Microsoft, Oracle, MySQL, you name them, everyone rolls their own set of additions. So they have additional features that are not part of the standard, extend it somehow. But also, sometimes they leave away things that are actually part of the standard. We'll have an example of that later. And yeah, the concept of null gives us great fun all the time, doesn't it? So when you have a Boolean variable, you don't only have true and false, you also have null, which makes it a three-byte logic. What Boolean actually should not be, but yeah, you know what that brings us. White space is ignored, so you can format your queries for good readability. Couple decades ago, when I learned the language C, I had great fun in putting all my stuff on one line. You know, you could do that with C, and it would work all the time. Of course, you can have your whole query in SQL in one line, but that's not good for the readability. So, but you can give it line breaks and tabs or spaces or whatever, which is ignored when it comes to the function. It's just for optic reasons and for readability, of course. Okay, now let me see. When I learned SQL, probably it was divided in two sub-languages. These days there are four. And I've been to an event where a guy had a fifth category. I don't even remember what that was. So you have the control language, which is actually about user permissions and stuff like that. You grant the user permission to see data or to call a procedure or something like that, and you couldn't revoke it again. You have the data definition language that's all about the metadata, so the structure of your tables, the data types of your columns, and so on. You have the data manipulation language in the closer sense, which is insert, update, and delete. And actually, lately, the select statement gets its own subcategory, being the data query language. So back in the days, I guess the select would be part of the DML. And I'm not sure what the DCL stuff, where that was, if it was in the DDL. We didn't have a name for it back then. Okay, we're concentrating now a bit on the select statement, and we'll see later why. A select statement, it can have several clauses, starting with, well, of course, a select. So you have the select column lists. You can do column aliases. You can do also aggregates. And you see you can do like a top number of rows or distinct column, blah, blah, blah. Uh, and yeah, the silly numbering here, we'll get to that in a minute. Let's just break it down from top to bottom, okay? Next up, we need a from table so-and-so, and the from doesn't need to be limited to one table. You can have multiple joins, take data from multiple tables where you have a join condition for everyone, and so on. You should have a where constraint, which limits the number of records you get back on certain criteria. Then you can have a group by, which plays nicely together with the aggregates in the first line. If you want to constrain on the grouping you have having, we have an order by, and we have a limit something, offset something. So that might look a bit strange. We'll see why. And now when it comes to the silly numbering, why is that there? Well, that's the order in which all those clauses will be analyzed and actually processed by the engine. So first comes the from clause, and then the where, and then goodbye, blah, blah, blah. And then at place 5 only comes the select clause. And also that's the reason why if you use column aliases, for example, you can't use the alias in your where clause, because the where clause is analyzed before the column list comes into place. Okay, so, and then if you look at number 8, the limit n and offset n. Limit n is a part of the SQL standard. If you want to limit the output to like, I don't know, 10 rows or something, the standard says to use the limit clause, which is something the SQL server that we all love does not understand. And that's why we have the top n clause, like you do select top 10 something. So I guess that all is not new for you. Just, okay, I have prepared an example for folks that are not really so familiar with the SQL. I'll just quickly go through it here, just to have a visual impression. I have a SQL server running somewhere, and it's probably, I hope it's the most current version. You see it here, I've got a couple of databases, and we're using the standard AdventureWorks. And if you go at least, you already see the red squiggly line here. If you try that according to the standard, yeah, you get an error because SQL Server doesn't know about the limit. That's what I said. That's why we do it like this. If we want to limit this to 10 records, we do it like that. No. So my screen is a bit wide. Yeah, it's 10 records, all right. Let me see. Okay. Select star is frowned upon. So you for production, you always should have like a column list, of course. Okay, you can have multiple joins. That's something we saw. I take data from the sales order, join it to the customer and the person to get at whatever the first name and middle name and last name and all that sort of stuff. So this won't work because I use, where is it? I use an alias for the country code and I try to do the where on the alias and it says, whoop, at that place, I don't know about any column that's called country. Because as we saw, the where clause gets analyzed first and yeah, the alias up here comes later. Okay. I see some chat popping up. Everything okay? Because I have that on the other screen.
Everything okay, no problem.
Okay. Yeah. Let me see. If you want to do the where on something, you can have to do the whole column name qualified because yeah, the alias is out. Yeah, you can do group by. I mean, that's for you. It's nothing new. Let's just go through this. Can group these by, let's say, country, territory, blah, blah, blah. And then you have aggregates such as the count, order count, or you can sum the total, whatever you like. You can limit that with the having clause. You can order that. And here we can see, yeah, the order understands the alias because the order by is analyzed later than the select line. So it's a bit nasty because in one clause you can use the alias and in the other you can't. Like this, yeah, of course. Now you can do this and you have the like top 3 here. I guess nothing special for you folks. Right. Let's see. Where are we going from here? Well, KQL, the so-called Kusto Query Language, which is the language used by Azure Data Explorer. That's the thing where I'll be running my demos in just a moment. And there's lots of places where KQL is actually used. If you're coming from the big Azure world, real-time analytics, there's Azure Monitor stuff, log analytics, blah, 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 you name it, it's there. I'm not so much of an Azure cloud person, I must admit. So I hope it was clear from the abstract that we're not coming from that side. So we're coming from, this is a low level approach. We're coming from SQL and taking a look at the basic KQL in a moment. And also have some practical examples, but not so much the way it's used in all the Azure parts here that are mentioned. Okay. But anyway, so lets you gain insights about your IT, blah, 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 from large data sets in near real time. So it says near real time, because when you actually ingest large amounts of data, there might be a slight delay in it. So it's not actually real time, but that is in the seconds, a second's gap, I would say, not much more. So a Kusto query, just like a SQL query, but this one is a read-only request. So in the meantime, they introduced an update statement somewhere, but that's a dot statement. So it's not really KQL. And from what I understood of it, under the hood, it does a delete and insert. So it's a bit weird. But in principle, you ingest your data, and then afterwards, what you do with the KQL is read only, because you wanna analyze it, you wanna get insights out of it. It's not so much about modifying it in large scale. So, it's a plain text, just like SQL. It has like in English language keywords, and it will be evaluated top down. So that's one of the most important differences here. You really can write it from top to down, and it will be evaluated in that way. We'll see that in the examples. And also, like just like a SQL query, you can have one more statement. You separate with a semicolon. That's not very sophisticated. Yeah, a statement usually is a tabular expression. It can be a let statement. So anyone who started development with BASIC, like I did decades ago, there was this let statement that would define a variable. Let I equal 1. And in BASIC, you can always omit the let, so you can just write I equals 1. We have that one here. We have set statements for certain purposes, and these statements are separated by a pipe. So just like when you do a lot of Linux, you usually have pipe symbols to transport the results of one part of the command to the next. That's nothing new. And then you have management or control commands. Those are the ones that start with the period. Like I think the update statement is a period update. So it's really in between somewhere. But they are used to ingest your data or also export it to other places. And Kusto, why Kusto? Yeah, actually, the developers thought of Jacques Cousteau. I think he was a French guy, or was he Belgian? I don't know. I think he was French. He was rather famous for doing greater tours and diving in the oceans to find hidden things there. And so just like we are diving into the data to get the insights up. Okay, next, what we mentioned here, a tabular expression. That can be, well, actually a real table reference, like what we had, sales header, sales order header, or something like that. There can be filters, projections, we'll show that in a moment, that also, as a result, give a tabular expression which can be used in the next step. Um, Rendering operators, actually, they do graphical output, but yeah, they consume the tabular expressions, and in certain circumstances, they can give it back also. We saw already connected by the pipe. There can be table literals. We'll have examples for that. The rendering statement, as I said, usually puts the result into graphical output, like a visual visualizations. Is usually the last statement in a query because you do all the preparation up front, filtering and summarizing or what, and then at the last step you do your visualization. Yeah, that statement, as I said, it can define a variable, and that can be a simple scalar, like I equals 1. It can be actual tabular value, so you can define with the let something that gives back a table. And it can be a function and also a virtual table, so it is quite versatile. And the set statements, yeah, they set option values for your query. Let me see. What are we going to look at actually next? It's the Azure Data Explorer, which is the online solution to handle KQL queries. So fully managed, yeah, fully managed means usually SaaS or whatever it's called. It's the online solution. High performance, yeah, it's really fast. We'll see that for big data, of course, it has to be. And there again, we have the near real time. So this is a quote by, I don't know where it came from, somewhere in the Microsoft marketing sphere. End-to-end solution, yeah, ingestion, query, visualization, so blah, blah, blah. But yeah, it's true. So it allows for advanced analytics and the visualizations. And as we also saw, user-friendly query language. We'll see the details in a moment because English keywords top to bottom and so on. It's probably the most powerful Azure service you've never heard of. So that was a quote by Patrick LeBlanc. I hope that changed in the meantime a bit, so people have heard of it, but may not know so much about it yet. And we have the possibility, and that's where I work in the moment. It can be tried without costs by using a free cluster option. So everyone can just set up a free cluster and then get the experiments going with the KQL language. Alternatives are Kusto.Explorer, which is a Windows app, the Kusto extension for Azure Data Studio. In the Azure world, there's also a CLI, so a command line interface, which I have not used until now. So let us see. This is the actual Azure Data Explorer. We see that live in a moment. That's the Kusto Explorer app, which can be downloaded from the Windows, what's it called? Windows Store. And you see up top, it has the ribbon just like the Office application. So it's a bit made to be user-friendly, and well, it's not bad because you get to the visualizations very fast at the top and so on. But as I said, it's only a Windows application. I'm running a Mac, so I'm out, usually. And also we have the Kusto extension for the Data Studio, but that is a version 0 point something, and I think it hasn't been touched for a year and a half. So I don't know why it's there at all. Okay. So this is the environment Azure Data Explorer. You go to dataexplorer.azure.com and it welcomes you with this page. And yeah, it's rather user friendly. You can get started with some hints here. You can from here create new queries, dashboard tables. Yeah, this is a bit Microsoft badges. You can do the Kusto Detective, which is quite funny. That's an online challenge where you have to solve Kusto queries in Kusto actually. Okay, but yeah, you have an intro to the Data Explorer and you have links to all the documentation. And if that takes you to learn.microsoft.com, it's really good. So I have most of those in my resources list. Let me see. Then yeah, we'll get to that in a moment. And that also here is the metadata for my cluster. It has a URL. You can start here ingesting data and querying or creating a new database. And you see at the bottom, I have two databases here. We can generate dashboards. We get to that at the end, but mainly we'll be here. No, let me see. Check. So on the left where it says demo cluster, this is my free ADX cluster, which I set up for these purposes. And I have two databases in here. And the query part, the bigger part of the screen, right? So in this database, I had ingested some of the tables from the AdventureWorks. I had to modify them a bit. So, but in order to replay the examples we saw just then in the SQL environment. Yeah, you can open the command palette to have your help. It has a context-sensitive functions. And from here, you can open resources like the SQL to KQL cheat sheet. Sorry. Yeah, let's just take a look at this. And where you can look up for your SQL query parts, and it tells you how to do this in KQL. Very briefly, it's just like two screen pages. But it helps you maybe to get started. Not that bad. And also from here, you can go to the KQL quick reference, which has all the KQL commands if you get stuck and don't know about parameters and so on. Yeah, you can always pin to dashboard. You can export your results, and you can from here open a couple of tutorials that have demo data, and then they take you to some basic steps working with KQL. Oh, you can upload a KQL file. I should have prepared this. Where are we? Data mines. Oh no, yeah, KQL. Okay. So on the top, we see in which cluster we are and which database we're using, and you can guess I did this session at some event in Erding last year. And well, let's just start and run some of this. You can show the diagnostic, which basically tells me is my cluster healthy, and then what's going on here, what are the statistics. You can have the database schema, which is a bit, yeah, it takes time to get used to it because you have the whole database broken down into table, column types, all in one result set. If you need to have the schema of one of your tables as JSON, you can have that. Or you can show details of your tables, and that says like the size or the row count, like this table has only 10 rows in it, and there's a couple more information about the table. Okay. So KQL has limited support for the direct use of T-SQL. So they say if you start your query with a dash dash, you can just give it a SQL query. And it's true. So down here we have the top 10 records from the sales element. But in fact, that works even without the dash dash. So you can just enter the select statement. I don't know why they tell us that. So for simple SQL queries, it might just work like that. To get from SQL to KQL, there is the explain command, which translates SQL to KQL. So if you have the select top 10 and you say, explain to me what that looks in KQL, you can see down here, it gives you back a KQL query, and I copied that up here. And we can see how this works. So it starts with the table, actually, and then you have a pipe and a projection. In this case, the select star gets broken down into the complete column list. Okay, you can do that, but you don't need it necessarily. And my top 10 that was in the SQL statement gets transferred to this one, take, and to make sure it's an integer, number 10. So that takes something, it's just the KQL syntax for the where you would use the top four. It doesn't need the integer. So you can have that much shorter by doing this. Because this says, give me all the sales header in principle, so all the columns, and the next one says, give me just 10 rows. In no specific order, just like the top 10. If you don't use an order by, it just gives arbitrary 10 rows. So actually, the explain makes it a bit unnecessary complicated, I would say. Okay. So if you want to, yeah, if you want to do proper, even if you like, we would call it a column list. This is called a projection. So you do a give me sales header, but project only those columns. And project is the proper name for that. It's not that it's KQL specific. You project to those four columns, and you get your result. I played around a bit with the explain command further, so I took the join construct and told it to explain to me what that would look. So again, you have the result, and I copied it up here for you, which is this one. And you can see we start with the sales header and we do a join. And the syntax here is it don't say inner join, you say join, and the kind is inner. And then you do project, let me see, you can do project rename, which basically is alias, blah, 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 blah. But you see here, there's some squiggly lines in the query that the function gives me back. So we have here like, yeah, a function that's deprecated already. So the engine knows it is deprecated, but still with the explain command, it gives me the suggestion to use it in the first place. Seems strange to me. And then, but that wouldn't be a problem. Back here, there's a real red squiggly line. It says, "Yeah, boo, here's an error." But hey, you gave it to me just now. So if I try to run this, it won't work. That's a real syntax error. So I would say this explain command is of limited use. I think you get the picture. Okay, but yeah, let's see all the things that we did with the SQL queries we can do here, of course. So that's a proper join with the projection and the take 10. And you see here that join is always kind is inner or outer or level, whatever. And it has the syntax that you do $left column equals $right column. See, yeah, as I said, top-down approach. I use an alias here, and I can use the alias in the next line because it gets analyzed and processed top to bottom. So if in line 70 I have an alias, anything from line 71 knows about it. I can use it in the where clause.
Thomas, would you like to handle questions in the end or answer questions now?
Good question, that. Are there questions already?
What if you throw the explain result into Copilot for correction with a question mark? Did you try Copilot? I think that translate the question into.
I don't know. I didn't try that. I just thought it gives me errors, so yeah, I don't bother much about it anyway.
That was the question.
I didn't try to get it any further, not in Copilot or anything like that. Okay.
Okay.
So, where were we? Like here. Okay, yeah. Aggregates. We have a sales header, we join a couple of tables, and if we need aggregates, there's the keyword summarize. And it takes aggregation functions. You can give that a proper column name. And the group by is in the same row at the end. So usually in SQL, you would do the count and the sum in the select line, and then do a group by country and blah, blah, blah. With KQL, it works just like this. You have the summarize keyword and all the parameters just behind it. Okay. Of course, we can, we can limit it. We can sort it, order by. That's all the stuff we just did there. Let me see. We can have the top 3. Oof. Okay. So, we're leaving the sample data for a moment. You can always add a new connection, which is called help. And that makes the so-called help cluster appear in your connection list. And there are some databases with sample data that are provided by Microsoft. You add it with the add connection. Now, as long as we have this session open, we can use it. The next time you log in, it'll be gone again. But you could always just add connection help and it will be there again. So, because they have some, which I have to click here so it gets up there. Yes. We have, let me start here. We have a table with storm events, which has, let me see, where is it? Yeah, 59,000 rows of storm events in the US. And storm events means anything like this here. So there is blizzards, there is dust storms, there's flood, and then thunderstorms, and whatever, tornadoes, and so on. Now, if you want to search for something specific, like here, of course, we have the where clause. I want to see just 10 of them. And you have the double equal signs in this case for the comparison. Some languages do with a single, some do with a double. So KQL does it with double. So we can see all the storm events where the event type is flood. So event type here, flood. That is case sensitive. So if I'm lazy, I don't do the capital F here, it won't find anything because it was with a capital F. So if you're lazy like me, you will tend to do this one, and it has a special name. It's called equal tilde, and that makes this case insensitive. It's just like a equal, but it's case insensitive. So I can write the small f, and I still find the capital Fs. That's some funny properties here. Let me see what next. We have, I always have to think about that one. Okay. So we can search for well, let's call it substring with contains. So that one will find the substring anywhere, and that one with has will find it only if it's the whole word. Let me see. I think it gets clearer when I show that. This one contains flood. It also finds those things like flooding and then other combinations. And if you want to just search for the real word flood on its own, you will use has because that it has the word flood and not flooding. So with those cases, you can spare the wildcards like asterisks at the front and the end, and have it still to your needs. Then we have the search command, which is quite mighty because it searches on all columns in a table. Yeah, beware. So if you have real big data sets, that might be not too responsive, but yeah, still. That, funnily enough, is not case sensitive. But in this form, it only finds the whole word flood. In that case, if you want to find flooding as well, you have to use the asterisks. It's not really strictly consequent how they do it, but yeah, that's the way they do it. Okay, then we have let statements, like this one here, let n equal 10. So that's how we all started when we started with basic programming. Let n be something and so on. But you can have strings, of course, like this. You can have dynamic assignments, like this is a function that gives me the date that was like 12,000 blah 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 days ago, and puts that into the variable cutoff, and you see that one is a date time. And then you can use the variables from there on in your queries. So I want to have the storm events where their start time is bigger than, well, what I defined as a cutoff date. And the state is what I defined as a place here. And I want the tab like N10 in this case. So I want only 10 records. Of course, for a small query, it looks silly, but if you use like the place in several in several places in your query, it makes sense, of course. But the let can do more. Let's see, we have here a string. So I have a string, I'll let that be Guam. And then the next let will generate a table for me. So this results in a table because what happens here is I say the Guam stores will be all of the storm events, which is a table, where the state is the place I just defined. Okay? So I place one variable called place that holds a string, and I have another variable that returns a table. And I use that string to filter the table. So if I do that, I define my place, I define my GUAM storms, and I give back all what is in GUAM storms, and that's those 4 records. So I think that's where it gets interesting if you can do such constructs like this here. The range, I'm not sure if SQL has it, so you can define a range just like from to blah, 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 and give that back as a table. Other people use, the integer tables. You need some integers from to, or you can also have like date intervals and so on. And the last thing I want to show you here, I have one integer here again, and with this multiply, I define a function. I define a function that takes value 1 and value 2, and it will return the multiplication of the 2. Okay? And then I use it on the range, and then I can do the multiply, and with that, in German we call it das kleine Einmaleins mit 5. Can somebody translate that to Flemish, please? So it's just the equal multiples of 5 here. From 1 to 10, each multiplied with 5. So it was just to put the range and the function into one. Okay. There is lots of more features and functions. Let me see. So, quick recap of what we saw so far. A limited subset of T-SQL, so if it gets too complicated, it's probably not. The explained functions, yeah, limited, as we saw. It tends to give back deprecated things and even hard errors, yeah? Oh yeah, the special behavior, the default sort order is descending. So if you do an order by whatever, it's descending, and if you want it ascending, you have to do the ASC, yes. Also, the default, as we saw, the equality check is case sensitive, unless you do the equal tilde for lazy people like me. Oh yeah, what I don't have an example for, the union, like if you want select blah blah blah, union select something else, it allows for different table schemas even. So in SQL, when you want to do union, the first and the second the table variable, shall we say, need to have the same table schema. In KQL, that's not necessary. It adds up the columns. And we have the search, which works on all columns in a table, which can be rather useful. But yeah, once you reach a certain size of your tables, beware of the runtime of this. And the go, which I found quite a funny function that is built in for datetime calculation. Okay, it takes us to the next level. And we're going back to my data here. We saw something like this before. We take data from the sales header, we do a couple of joins, we do some summarizes here, like counting orders or summing the total value, blah, blah, blah. And if we want to visualize that, we just enter a render clause at the end. So the render clause takes several parameters, of course. So for the first one, I say I want a column chart. Stack one, I give it the columns and a couple of more parameters. Let me just invoke this for you, and it gives me a column chart. And if you have it here in the Data Explorer, you can hover over it with the mouse, and it gives you details of what your data points actually represent. And also you can do some formatting, as you can usually do with your visualizations. Okay. Okay, there's more possibilities for the render clause, of course. Yeah, that one gives a table, which looks a bit silly, but in order to use it on a dashboard, you have to actually render it to a table. We'll see that in a moment. Yeah, this one would be for Benny. Sorry that he's not here. Pie chart. Anybody else fond of pie charts, or is it only Benny? I don't know.
Anyone?
Of course. Huh?
Anyone? No.
Power BI guys hate pie chart. Yeah. Okay. No. So I'm not sure why Benny is so fond of them. I have to ask him. Yeah, but nothing special, of course. That's a pie chart. Without that, it wouldn't be complete, would it? And you can have a line chart, of course, yeah, and have points here. And always, if you hover over it, it gives you the actual data that's behind it, and so on. Oops, where am I? Yes, and what you always can do is pin to a dashboard. Let me just see if I. Let me see. What have we? Yeah. There we have all the visualizations I just shown. I just put them on one dashboard. And even here on the dashboard, you can hover over it with the mouse and it gives you all the data. And you can edit it here. You can download the dashboard to a file and you can share it to other people within your company. Let me think, within your tenant, I guess that will be. And save it as blah, blah, blah. Yeah. Okay, well, let's get back to the query. We have again, so we go to the samples database once again. And we get back to the storm events because let me see. Yeah, that's a card. We can do a bar chart like this. And personally, my favorite, you can do a map. So in that case, it's a scatter chat with kind map. So it's not it's a subtype of the scatter chat. And that gives you, because there are, of course, coordinates in the database or in the table rather, it gives you, what does it do? It gives you a map of, stay there for me. It gives you a map of where the storm events happen, in this case, all over California. And also you can throw that onto a dashboard. And what you can do here is even build in filters, like we filter here on the states. If I want to see Alaska, it dynamically changes also the map. So also the map. So those are the storm events in Alaska, or I don't know, where is, yeah, I think Florida. Yeah. There's always a lot of events going on here in Florida, so you can build in filters and have all your visuals react to that. Yeah, also the maps and also the bar chart here. Oops. So you see, no injuries, no deaths in Alaska, but still damage of $4 million. Okay, back to our query. So there's another table in here which is quite nice. That is the trips table. It has trips of the New York taxi companies, and it has a row count of, well, 1.5 billion. And if you look at that, it is also, yeah, and I don't know why those are red. It's the standard data from Microsoft. Something is wrong in the structure. That has been the case since I first opened the help cluster, so I can't help it. And there's quite a lot of information about those taxi trips from to and coordinates and costs and you name it. It's there. Oh, let me just. What happened now? What did I do? Okay. Whoop. No, I think I broke my screen just for a moment here. There you go. There we were. And funnily enough, it only has two types of caps, the famous yellow caps and something called green caps. I'm quite sure in New York there are more taxi companies than that, but that's the way the data looks. And what we can do now here is some time series analysis. We can build a time chart. Like you can see that yellow caps have been around for forever. And you can see down here that the green cap started somewhere in 2013. So it's rather old data. You see it stops here at like 2018. But to play around with and to have an example, of course, that's enough. And then what you can do, I'm not a specialist for time series analysis. There's other people like Gianluca probably. But still, like this, oh yeah, I cut it down to the year 2015 only. And then you could do like this, for example, anomaly detection, because there are, of course, some ups and downs here, but now what is really an anomaly? I only took the yellow cap data because the green is not so much. You see, I filtered down to the yellow here. And you have lots of time series analysis functions here, so you can generate the anomalies and show them in an anomaly chart. So this is a special function. So you don't have to like pick them out and then make them into a graph of their own. It just shows you with the red dots, and I think when I hover over it, the red dots have gone. Where the anomalies are according to these parameters. Now, as I said, I'm not a specialist, but you can have several parameters and play around and twiddle them in order to influence what is regarded an anomaly, for example. Okay. And what I was told the time series guys like to do is a decomposition. That is also, oops, no. Now what happened? Okay. I zoomed in too closely. The decomposition, it takes the data and breaks it down to, let me see, the baseline, the seasonal effects, the residuals, which is sort of an explanation for the errors that are in there, and a trend line. So of course you can tell by the data when looking from it from a bit further on that the trend line is going down, but that is the actual calculated trend line here on the bottom. Okay. And it does that all, well, almost automatically because, well, here you can extend it to baseline with the decompose function, and it gives you all that information, seasonal, the trend, the residuals, and so on. And then you do a time chart rendering with the decomposition, and it gives you that one. And as we saw, it can do a trend. Last thing I'd like to do here, does that? Yeah, that shows. The blue line on the top is the actual data that is in there, and you see there for this query it stops at like January 1st, 2016, and the bottom line is the forecast, which of course uses all the data until here, the actual data, and then forecast the trends, how it will develop further on. And from here you can also see, if I move my mouse away, there's a downward trend in here, just like we saw before. So that's something you can do with KQL and with the Azure Data Explorer. Okay, right. So that brings me to the end of my demo. And for a quick recap, yeah, visualizations, they are only a render clause away. So when you aggregated and formatted your data, just add the render clause, and there's multiple possibilities what to make out of it, including the maps. As we saw, there's a possibility for geospatial clustering, which is probably a topic for another session, I guess. You can always pin the stuff to a dashboard and edit that dashboard to your likes. We saw it can be filtered, like we had with the states and the storm events. It can be exported and shared, and it has built-in time series capabilities, including anomaly detection, decomposition, and so on. Okay, so those were my resources, and most of them, as you see, point to learn.microsoft.com. And I must say, I mean, I was used to books online from SQL Server a while ago. That was so-so. But ever since they moved all of that stuff to Learn Microsoft.com, it's really good. I mean, who knows me is I never avoid a good Microsoft bashing, but I must say this platform is really good. It's always up to date. It has all the content. So if you're looking for anything for those Microsoft products that we deal with, go there, you'll find it. In the middle, the ADX free cluster, if you go there /free cluster, you can set up the free one, as I mentioned, to play around with without any costs. And also there is an ADX in a day offering, which is a bit different than the usual, like, what is it, dashboard in a day. Also, this one is on GitHub. It's in 2 parts. I hope it's still there. But it has all the explanations, and it has it has 2 labs you can go through with all the explanations to get you going with with KQL. Okay, so that leaves me at this point. Thank you for your interest. Thank you for your time.